in this unit is how to expand and how to factor. Okay? And we said that expanding is the opposite of factoring and vice versa, right? So whenever I want to put it in factored form, I have to factor, and then if I want to go from vertex form or from two brackets multiplied together to the expanded form, I have to expand. Now, one of the forms of quadratic is called the factored form. And that's why we learn how to factor. Because remember, there's three different forms of quadratic. We learned the vertex, right? We talked about the expanded form, the standard form, right? And we said that the standard form is useful so I can find the y-intercept. But the third form is the factored form. And then to go from standard, so to go from the standard form to the factored form, I have to know how to use all three different forms of factoring, right? Now what we're going to look at today is why is the factored form useful? What can the factored form give me when I'm graphing? Okay, now my question to you guys, vertex form, what was it useful for? The vertex, which gives you either the minimum or the maximum, right? And then you can use your step pattern to graph, correct? Remember that? And then what did we say the standard form is useful for? The y-intercept. Now we're going to look at what is the factored form useful for. Okay? So the factored form looks like this, where you have the two brackets. And this is what you were doing yesterday in the quiz, right? With the quiz yesterday, let's say if you had, I don't know, I'm just going to come up with something here, x squared plus 3x plus 2, right? You were looking for two numbers that multiply to what? Multiply to 2 and add to 3. So what multiplies to 2 and add to 3? Multiply to 2 and add to 3. 2 and 1, right? And then you factor it to x plus 2 and then x plus 1, right? So what we did yesterday, or what we did in the previous lessons, we went from standard form, right, to factored form, right? Now, why do we need to know that? That's what we're exploring today. So, if I look at this graph and this equation here, right? So from the graph, I'm going to try to find all my key features. So I'm going to just zoom this in a little bit, okay? Can you guys tell me where the zeros are? Yeah. And remember, I write the zeros as x equals to -2 and -1. So I have the two zeros. One is here, one is here. Okay? Where is your y-intercept? Y equals 2. How about the vertex? Where is your vertex? It's like in between the -1 and the -2, right? It's in the middle between them, because remember that the vertex has to be in the middle. It's the axis of symmetry. It's like, because of the symmetry, it has to split it in half, right? So it's about -1.5. And that looks like to me 0.25, -0.25. So my vertex is -1.5 and -0.25. How about the axis of symmetry? X equals to -1.5. And how about your optimal value? -0.25, and it's a min. at my second graph, where are the zeros? Can you see them? -3 and 1, right? So you see x equals -3 and 1. How about your y-intercept? Where is your y-intercept? It looks like it's around 6, yeah? So y equals 6. And how about your vertex? -1. No, it's not 6. It's 8. -1 and 8. So -1, comma 8. How about your axis of symmetry? X equals -1, and the optimal value, y equals 8 and 10 minutes. All right. Now, if I'm going to look, so I just looked at the graph and I got all this information, right? Now, if I want to look at the equation, what part of these key features, which key feature kind of or match your equation? So if I'm looking at the equation here, right, this equation here, what part of my key feature is matching or somewhat matching the equation? Yeah? The zeros? So what are the zeros for the first one? What are the zeros? -2 and -1. Where do you see -2 and -1 inside your in the equation? In the brackets, but what do you see? You see the opposite sign, right? You see 2 and 1 in that bracket. How about for the second equation? Do you see -3 and 1 or the opposite sign, 3 and 1, -1?
Yes.
So this here, the zeros match whatever is with the x inside the bracket, but they're opposite sign. Do you think that's always going to happen? Yes. All right. So the factored form will give you your zeros. Will give you when the graph intersects the x-axis. So vertex form gives you the vertex, right? It gives you the vertex. The standard form gives you the y-intercept. Factored form gives you the zeros. So each form is useful for something. All right? So, can you take from this equation an equation in factored form which looks like this? Y equals A, x minus r, x minus s. This is the general form for the factored form. Okay? This is how we write the general form of the factored form. Tells the location of the x-intercepts, or the zero. In order for me to find the zeros, I have to set each bracket equal to 0 and solve. So, eyes on me for a second, please. So look at this. I'm going to take your second equation right there. So y equals -2, x plus 3, x minus 1, right? In order for me to find the zeros, I have to set each bracket equal to 0 because I'm looking for the zeros. So I'm looking for when the y is equal to 0. So what I have to do, always whenever you're finding the zeros, you're going to set each bracket equal to 0 and then you're going to solve for your x. So to solve for this x, what do? Bring the 3 over here. What happens when you bring the 3 over the equal sign? It becomes a negative. So that's going to become x equals negative 3. What happens when what do I do for the second one? So bring the negative over, and that's going to become x equals 1. Are these the zeros that I found? Yes. You change the sign. Okay? So remember, you're going to set each bracket to equal to 0. And then you're going to isolate for your letter. Okay? And that will give you where your x-intercepts are. Does that make sense to you guys? Isolate for the letter. It has to be in factored form, guys. It has to be in the factored form.
So what's the 2?
What's the what?
The 2 is just nothing then?
That's just the A value. So that's telling you that it's going to be opening down.
Okay.
Okay? What?
I don't know why we're going back on graphs.
So
Because you always want to be able to graph. Right? No matter what form you're in, right? You know, if I give you this one, you should be able to graph. And then if I give you this one, the first thing you're going to graph is your 2 zeros.
it's still a parabola.
It is still a parabola. It's still a quadratic. Right? So the first thing that you're going to graph here are your 2 zeros. And then we're going to learn at the end of this unit, we're going to learn how to find another point, which is the vertex, so I can graph the whole graph. Okay? It's a process. You have to graph. Graphing is one of the things that's why we solve, to be able to graph. Or if I have a graph, I need to be able to find the equation so I can have to be able to do both. Yeah. So factored form can be converted to standard form by what's the process called? Expand. So factored can be converted to standard by expand. So how would you expand something like this? What do? Foil. That's right. So I have to foil. So let's foil that. What's the first thing I have to do? X times x, which is? Then?
Then x times positive 1x.
Then negative 2 times x is negative 2x. And then negative 2 times 1 is negative 2. Okay? So, next. Collect like terms. And my like terms are the 1x minus 2x, right? Which gives me minus x. And my last step. Distribute the 3a, right? So that means multiply by 3, which is going to give me 3x squared minus 3x minus 6. Question for you. To you, when you look at this, does it look like this, but with numbers? Does it look like this, but with numbers?
Oh yeah.
It does, right? A is 3, R is 2, S is negative 1, right? If I do negative and negative gives me positive, right? So it looks like this. What do we call this form? Factored. Now, when I expanded, I ended up with this. Does this look like this to you, but with numbers? That's the standard form. So what I did here is I went from factored form to standard form. That's what I did. By a process called expanding. That's the actual word. If FOIL is the method, expanding is the process, is the name. Okay? Now, you guys learned that you can go from here to here. We learned that we can go from here to here. And what do we call that process? Factor. Common factoring, sum and product, right? Factor. So you can actually go from here to here, right? By a process called factoring. Remember, we always have to learn the way back. I can't just learn how to get to the store. I have to get back home, right? So that's what we're learning. We're learning how to go between two forms. Okay? Okay. So to find the zeros, what form does it have to be in? To find the zeros, what form do you have to be in? Factor form. So the question here is asking you, factor, then find the zeros of the relation. So you're going to have to factor first, then you're going to have to find the zeros. Okay? So, how many groups do we have? We have too many people here. So we're going to have to form 2, 4, 6, 8, 10, 12, 14, 16. So we're going to form 16, four groups of 4. That's okay. Good job. All right. 4 groups of 4. All right. So, and then what you're going to do, you can use the whiteboard at the back if you guys want. You can use the whiteboard at the front. And then for the other 2 groups, you can, how about, do you guys want to go to the back and use some whiteboards?